Never. Oh, real. It might be. I thought it was like vulgar or something.
All right, guys, page 10 in the packet.
But I don't know.
I like this.
I should do it myself. It's okay. There was something about, I don't remember. Yeah.
No, bro, I hate it.
Whoa.
Okay, we're just expanding on what we did on the Friday before break. We talked about principal values and we talked about how we have some restrictions based off of inverses. So when we're talking about inverse functions, we have to be aware that sine and tangent is restricted to the fourth quadrant if we're dealing with negative values. So we talked about how cosine is just first and second quadrant. But if we're doing arc sine or arc tangent or inverse sine or inverse tangent with the uppercase S or uppercase T, that means we're restricting to just the domain restrictions. So if we're looking for arc sine of a negative value, we have to understand that it's in the fourth quadrant. And normally fourth quadrant, we say 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6. We just have to make the adjustment that in the fourth quadrant, we're going to the left of the origin. So it's going to be negative pi over 6 in the fourth quadrant. If it matches 11 pi over 6, if it matches 7 pi over 4, we say negative pi over 4. If it's 5 pi over 3, we say negative pi over 3. If it's 3 pi over 2, we say negative pi over 2. We only do that especially with sine and tangent. With cosine, we just do what we normally do with first and second quadrant. Okay, so we'll review this as we go through this page on page 10. Okay, so I'll go through this one step at a time. Okay, and we're going to reference our unit circle a lot here. Okay, so number 1. Okay, so we always start inside the parentheses. Okay, arc cosine of root 3 over 2. Sine of arc cosine of root 3 over 2. Notice that this is uppercase A, so we know that this is talking about principal values, but cosine, but it's positive. So positive is just first quadrant. You don't have to do anything special with that. But understand that if it's arc cosine of root 3 over 2, let's first figure out what that means. This is another way of saying it is cosine of what angle is equal to root 3 over 2. That's another way of saying arc cosine, right? And so a cosine of what theta value is equal to root 3 over 2? Pi over 6. Yep. So we should make that substitution there. We know theta is pi over 6. And now we can replace this whole parentheses with pi over 6. And now we're just asking our question, sine of pi over 6 is equal to what? 1/2. Yeah. I think for this section, we're going to see mainly radian measures. Yeah, so it's going to be in radian measures. Yeah. Okay, so we're all going to do inside out. So parentheses first, resolve what this is talking about, and then finally we can look on the outside. Okay. Yes.
How did you get Like 3/2 to power 6.
Right, so if we think about our unit circle values, cosine of what theta value is equal to √3/2, cosine of pi over 6 is equal to √3/2. We're just working backwards here, trying to figure out what angle measure will allow cosine of theta to be √3/2. Okay, number 2. Okay. Uppercase A, but this is just 0, so we know it should be easy to find here. So in other words, tangent of what theta value will give us 0. Two pi or, well, 0. Yeah. So remember with our tangent, we're only looking at between negative pi over 2 and pi over 2. So we're just going to involve 0. Okay. So we're just replacing theta with 0. Are you okay so far? Okay. So now that we know that tangent of 0 is equal to 0, now we can look at our outside parentheses here. Cosine of 0 is equal to what? Yeah. Okay, this looks more complicated here, number 3. But we're going to start inside here. Inverse cosine is equal to negative 1/2. Now we see uppercase C, we see negative, but we know that with principal values, cosine is just going to be how we normally would think about it, just in the second quadrant, right? We know cosine is negative in the second quadrant. So we're looking for a theta value that will allow cosine of theta to be equal to negative 1/2. What theta value will allow cosine of theta to be negative 1/2? 2 pi over 3. Yeah. So I'm just going to replace this whole thing with 2 pi over 3. Now I'm just going to rewrite this problem here. Let me highlight the substitutions that I'm making here. Okay, so I'm cleaning that up to just be 2 pi over 3. Everybody okay so far? Okay, so now it becomes more straightforward. Multiply this through, what do I get? 4 pi over 3. And now it's just a straightforward unit circle question here. Tangent of 4 pi over 3. Right, we look in the third quadrant, tangent to 4 pi over 3 equals y over x, right? So √3 over 1, which is just √3. Yeah, question.
How did you know to simplify the cosine line like down to just cosine?
Say it again.
Like, how do you simplify the first part to just cosine theta?
So this is arc cosine. So when you see this notation, it's really representing an angle, because if I were to move this cosine over, that would turn into Right, so inverse allows this cosine to switch over to the other side. So inverse cosine just means that I'm flipping over that cosine notation to the other side. Yeah, so whenever you see this inverse cosine, you know that ultimately it represents a theta value, an angle or a radian measure. Okay, number 4. Okay, so this one's a little bit different here because this is not, we're not going to start with the outside, we're going to start with the inside. Now that we're just looking for sine of pi over 3. So we're just getting a ratio here, right? So what's sine of pi over 3? Root 3 over 2, right? So now we do arc sine of root 3 over 2. So now we're looking for the radian measure, right? This is another way of saying this is sine of what angle measure or what radian measure is equal to root 3 over 2. Uppercase A, but it's positive. So if anything is positive, we only have to worry about the first quadrant, right? It's only with negatives and uppercase S, uppercase T that we got to deal with these, that we got to make some adjustments with these negative values. But if it's positive, first quadrant, right? So sine of theta, what theta value will allow sine to be root 3 over 2? Pi over 3.
How do you know that it couldn't be the 2 pi over 3? How do you know it's in the first quadrant?
Because with principal values, you see that uppercase A,
Yeah.
that means we're restricting our domain to just, because it's an inverse function and it can't exist past those points, it's just going to restrict itself to just be either quadrant. If it's sine, it's just quadrant 4 and quadrant 1. If it's tangent, only quadrant 4 and quadrant 1. If it's cosine, it's quadrant 1, quadrant 2. So for sine, if it's positive, it's always quadrant 1. If it's negative, then we got to make an adjustment. But if it's positive, we're always safe. It's always quadrant 1. Number 5. Okay, so let's start inside here first. Cosine of 3 pi over 2, what's that equal to? 0, yeah. So now we're going to do arc cosine of 0 or inverse cosine of 0. In other words, cosine of what angle measure is equal to 0 or what radian measure is equal to 0. Cosine of what is equal to 0? Pi over 2. Get pi over 2. Cosine, we're looking at just between the first and second quadrant. So we're not going to involve 3 pi over 2. It's only going to be between 0 and pi. Okay. 6.
Cosine 3 over pi. Cosine 3 pi over 2 is taking out 0.
Yes, cosine 3 pi over 2 is 0. But then we're turning around and asking, what's the inverse cosine of 0? In other words, cosine of what angle measure is equal to 0, and that radian measure is pi over 2. Pi over 6 or cosine. Yeah, 3 pi over 2, right? Yeah. Okay, number 6. Okay, straightforward here. Tangent of 11 pi over 6. Let's just think about our unit circle value. We're just going to get we're just going to get a fractional value here. What's tangent of 11 pi over 6? -3. So -1 over root 3 or -3 over 3. Either one's fine. I'm going to put -1 over root 3. But okay, so now notice this is uppercase A or uppercase. So we know there's going to be restrictions here. We know that arc tangents of negative, we got to worry about the fact that it's now in the fourth quadrant, and we got to make these adjustments. Okay, fourth quadrant, we're not going to say 5 pi over 3, 7 pi over 4, 11 pi over 6. We're going to go to the negative region. We're going to go to the left of the origin. So we're going to make these adjustments. So in other words, when is tangent of theta going to be -1 over root 3? Yeah, negative pi over 6. So instead of saying 11 pi over 6, we're going to say negative pi over 6. Yes. That's what we're working towards with the quiz on Friday. Okay, number 7. Cosine of 2 pi over 3 first. What's cosine of 2 pi over 3? -1 over 2. So now we're going to do inverse sine of -1 over 2. Now notice this uppercase S here. Inverse sine and arc sine are the same thing. So anytime you see uppercase A or uppercase S, you know you got to deal with these restrictions, and it's negative. So we know it's not quadrant 1. We got to deal with these quadrant 4 values here. So what theta value will allow sine to be negative? 1/2. In other words, So normally we would say 11 pi over 6, right? But we got to make an adjustment. Our domain restrictions and principal values, we're going to say negative pi over 6. Okay. Straightforward here, tangent pi over 4. And unit circle value was tangent of 5 pi over 4. So that's just equal to negative, or sorry, just positive 1, right? Yeah. Okay. Inverse cosine, positive, should be easy to find. Cosine of what is equal to 1? But remember, cosine is only between 0 and pi because of uppercase. So just what? 0, yeah. Cosine of 0 is equal to 1. Okay, number 9. Okay, sine of 7 pi, we know that these are coterminal angles, right? So if I keep subtracting 2 pi, I can make it more familiar. So sine of 7 pi is same thing as sine of what? Sine of pi. Subtract 2 pi, be 5 pi, 3 pi, 1 pi. They're all the same thing, but it's a little more familiar for us for sine of pi. What's sine of pi? 0. We're going to arc tangent of 0. In other words, what theta value will allow tangent of theta to be 0? 0. Okay, number 10 through 21. We're going to rely on right triangles to help us find these ratios, these exact values. So let's go to number 10. Sine of arc tan of 4/3. In other words, that's another way of saying that is tangent of theta is equal to 4/3. Now, this is not a unit circle value, but we can create a right triangle out of this. Uppercase T. So we know that it's positive. Positive is always going to be first quadrant. We're not to worry about doing anything special with first quadrant. It's only if it's negative that we got to put in the correct quadrant. Okay, where can we put the 4 and 3, knowing Socotella? It's a nice 3, 4, 5 triangle, right? Now we're just asking, what is sine of theta? So that arctangent allows us to fill out the triangle. This represents theta, so now sine of theta is equal to what? Yeah. So we use the inside parentheses to fill out the triangle, and then we use the outside to get that ratio. Yes. Because arctangent is not negative. Yeah. If it's negative, then yes, we'll have to put in the fourth quadrant. Okay, number 11. Inverse sine, arc sine, they mean the same thing. Okay, so in other words, sine of theta is equal to 24/25. It's not a special right. It's not a unit circle value, but we can still create information from this. Positive, so first quadrant. SOHCAHTOA, sine is opposite over hypotenuse. Pythagorean theorem can help us find that missing side. Okay, so now we're just asking, what is cosine of theta? Yeah. Okay. Inverse cosine, meaning cosine of theta is equal to -8/17. Now, uppercase C here, which quadrant do we want to be in here? Second quadrant, yeah. So cosine is just second. For negatives, for cosine is second quadrant. For negatives, for sine is fourth quadrant. We gotta put this in the second quadrant. Remember, your hypotenuse is always positive. Pythagorean theorem. Double check that it is a positive 15 because we're going left 8 and up 15, so y value is positive in the second quadrant. So now we just turn around and say, what is tangent of theta? Yeah. Okay, let's start from the inside. Tangent of theta is equal to negative 2/3. Uppercase T here. What adjustment do we have to make? Right. Tangent is negative in the fourth quadrant, right? So we got to make that adjustment fourth quadrant here. The negative goes with the y because we're in the fourth quadrant here. So positive right 3 down 2. So positive 3, negative 2. Okay, what's cosine of theta? Adjacent over hypotenuse. So you don't have to rationalize the denominator. You can, but I'll accept you don't work. Arc sine, uppercase S with a negative here. What adjustment? Fourth quadrant. You know the negative 1 is going to be with a, you know the 1 is going to be, sorry, negative is going to be with the 1 because the hypotenuse is always positive. Pythagorean theorem. Okay, what's cotangent of theta? So x over y, right? So
Wait.
root,
Isn't it the square root of 17?
is 16 minus 1.
But
So-
you have to square negative 1. don't you?
Right. So when I square negative 1, it's still positive 1, right? So a squared plus negative
sorry,
1
my
squared
bad.
equals.
I thought, sorry.
Yeah, so that negative 1 disappears, but then we got to subtract 1 to the other side. So negative root 15. That's just, it's over 1, but I just dropped the 1. Okay, cosine of theta is equal to 2. Is that possible here? Now, cosine is, your cosine graph is only going to sit between -1 and 1, so this doesn't exist. If this doesn't exist, we can't find something that doesn't exist, so undefined. Okay, 16 through 21, we're still dealing with triangles, but we're dealing with variables. But with the nice thing about variables is you only have to deal with the first quadrant. You don't have to worry about anything with the second or fourth quadrant. It's always just going to be the first quadrant. Any questions so far? Okay, so we're going to start inside here. In other words, another way of saying this is tangent of theta is equal to x. Now we like to have a ratio, so it makes it easier for us to fill out our triangle. So if we don't see anything in the denominator, you can always put a 1 in the denominator. And it's always first quadrant if you're dealing with variables, so that's nice. Okay, so what can what sides can I fill? Yeah. Okay, Pythagorean theorem helps me find my hypotenuse. Okay. What's sine of theta? Yeah. Opposite of hypotenuse.
The square.
That's fine. Yeah, know how to rationalize it. Okay. Cosine is adjacent over hypotenuse. Make sure when you do a squared plus b squared equals c squared that you're squaring both the 2 and the x. Now, you may be tempted to want to do the square root of 49 and square root of 4x squared and make it like 7 minus 2x. But there's a minus sign in between, so that prevents us from being able to clean up the like we would like to. Okay. If it was multiplication, then that's fine, but that minus sign prevents us from being able to clean up the way that you would prefer to. So it's kind of stuck in this form. So what's tangent of theta? Opposite over adjacent. Okay, these feel manageable with these steps? Okay, So why don't we finish off 18 through 21? I want to just kind of walk around, see how you guys do, and I'll put the answers up. And that'll be the end of today. You can always, and for all these problems, it's always first quadrant, so that's nice. You just have to enjoy your triangle in the first quadrant.
Seventeen y squared is like. Why is it still squared?
Oh, you mean
Yeah.
what? So we can't break this down because that minus sign. Yeah, so even though you want to take the square root of 49 and 4x squared, that minus sign prevents us from doing that, so we kind of just keep it that way. We're gonna be playing with principal values and also yeah, so we're just extending on this concept for the next few days, and the quiz will be on Friday, but we'll be able to review starting Wednesday, I think. Right? I don't think about.